My name is Elise Wright Knutsen. I'm from Norway, and I did my master's degree thesis at the Norwegian University of Science and Technology in Trondheim. Now I'm at the American University and at NASA Goddard. So my thesis was about the effects of energetic particle precipitation and how that affects mesospheric ozone, or in normal words, how charged particles from the sun affect ozone at about 70 kilometers in altitude. So we want to know about this because it's more important now than ever to understand climate change. And we have external forcings on climate, which could be human, but they can also be from the sun. And the sun emits photons and charged particles, and all the photons have been accounted for in climate models, but the charged particles have not. So that's what I'm doing. I'm looking at how the charged particles affect ozone, because if you change ozone, you can also end up changing the temperature of the atmosphere and the wind patterns. So what I found is that, so here you have the ozone, and the layer that I was looking at specifically only exists in the polar regions in the winter time. And when you have particles coming into the atmosphere, it will destroy the ozone, and you get a depletion, such as you can see here. Day zero means that you have an incoming storm, so particles are being injected into the atmosphere, and you have the ozone layer oscillating around a normalized level, and then it drops right after the storm. And you can see this for different storm categories when they're quite strong. By testing for different layers throughout the atmosphere, you can see that this dip in ozone happens all the way down to 55 kilometers, all at the same time. It does not take a long time for it to reach these lower levels. And because we can see this, we can conclude that the particles that are destroying the ozone has to be from the radiation belt, because it happens far down immediately. And we can also tell what kind of processes are going on, because it happens immediately after the storm and it's not a delayed effect. So from this, we can conclude that the solar particles are destroying ozone not just when you have a solar maximum, but also at solar minimum. And it's very important to keep this in mind when developing climate models, because it is actually changing the ozone, which is actually changing temperature and wind patterns.